Hello and welcome. This is the Bits vs. Bytes podcast. I'm your host, I'm Grigic, and today with me is Pablo Santos. He is the founder at Plastic SCM, and I would like to welcome you, Pablo.
Hello, really happy to be here today.
Sure. Could you tell me a little bit, and the listeners, a little bit about your background? So, how did you get started?
Okay, sure. Well, the story it's started to get long because we are in business since 2005. So it all started because we wanted to come up with a better version control system, and we saw that back in the time there were not that many good alternatives. There were some big version control systems up there like Subversion and ClearKits from IBM, but whether they were, super simple or too expensive. And the dream was to build something that was easier to use and quick and powerful and like all together. And that's why we started. The
Yeah.
plan B was actually developing a video game. So
Oh, video games, really? So, why was that? So, what was the kind of reasoning behind the video games part?
well, back then I really loved playing with OpenGL and DirectX and trying to learn how to code games and so on. And I'm also a petrol head. I always love like cars and motorbikes and all that. So we wanted to come up with something like a super big simulation game or something like that. I don't know, something like what we can see today in, well, project cars or something like that. Of course, we would have never get so close, but that was like a dream too. Like, okay, what should we go for? Like a video game or really develop a version control system? And well, the version control system won at the end.
Okay. And why was that? Was that more because of the knowledge being readily available, or why was that?
Well, that's a very good question, and to be honest, I'm not sure I remember the final reason anymore. But it was more like, okay, we, I wanted to build a company. I wanted to move forward and create a business out of it, and we were evaluating another co-founder and myself. We were actually evaluating the alternatives and trying to figure out what would be possible to have at the end. And I think at a certain point we said, okay, maybe it's more doable to go for the version control, considering our background and what we know and so on. And that was probably the main reason, right?
Yeah. So that's interesting on many ways because it's totally two different worlds, right? So version control system and video games is totally different. Yeah, of course, it's both. You could call it both software, right? I mean, it's not that different in a way. But I was wondering. So maybe you can explain a little bit about you wanted to start a company and how did you get started? Was it just starting with the code and going from there, or how did that process go?
Okay, so I actually had a couple of previous jobs, so I got more and more interested in version control and software configuration management and so on. I started to read several books and even to attend some events and speak about agile and mixed with version control practices and so on. And then at a certain point of time, I really decided, okay, it's time to actually make a move. There's a difference from when you are just thinking about it and really when you decide to move forward and make it happen, right? So it was around 2004 when I said, okay, it's now the time to actually look into it for real. We've probably been thinking about it for the last year, a year and a half or something. And then we said, okay, how do you come up with a business? So it's not only about the code, it's not only about the product, it's about the business. So we started thinking about creating a business plan. Back then was more usual than it is right now with all the, lean approaches and so on. But we actually came up with a pretty nice and detailed business plan, trying to figure out how will we sell it and how much it will cost and all that. We put it together and then we try to find investors. It was not a bad time because from an economical perspective, 2004, 5, and so on was not a bad time like it became later on. So our idea was, okay, if we cannot find anyone who want to invest, then maybe it's not worth moving forward. Of course, I will think differently right now because these days bootstrap teams are all around. But back then, that was our thinking. So we started basically trying to find potential investors and meeting with people and meeting with companies who were doing investments and even private or like business angels and so on. And basically around July 2005, it was a turning point because our first investor and business angel said to us, okay, let's go ahead. I will put some money into this and you can move forward. A few months before that, I actually quit my job because my goal was to focus on this and also like probably as a backup work as a version control consultant.
Mm-hmm.
And I did a couple of jobs on that. But then really just a few months after, like a couple of months or something like that, we got the green light to move forward and create a company.
That's interesting. Yeah, we can move multiple ways from there. But I was wondering. So maybe I don't know if you asked that angel that started the kind of funding. Why did they invest? So because I can imagine in that time there were some other version control systems as well. So why choose yours and why invest in that? Do you know?
Okay, well, at the end of the day, it was pretty emotional. I mean, it's not like I don't think he was super, analytic with it. So
Mm-hmm.
it was more something like, well, we met him by chance, thanks to another colleague of mine that, we are still quite good friends, and he just introduced me to this gentleman who was, a pretty well-known local businessman here, and well, he somehow liked the idea. I think he was in a good economical position by that time, and I think he got into the idea, not only that it was good or it was a good business or something, that he probably liked us as founders, and he liked the illusion, and he liked the you know ourselves as being able to make it happen, and probably he wanted to get involved into something like that. So that's why I say it was probably more
Mm.
uh, on an emotional side of things. Probably I never got the I mean, I cannot enter in his brain and get
Yeah, sure,
the
of course.
final reason. But my understanding after years, because at the beginning I just said, okay, yeah, it's going to be a good business for you and this and that. But after years, I think it was more on a probably like, yeah, I got excited by this, so let's make it happen.
Yeah, and that's what I hear a lot. And I talked to an investor a little while ago, also on the podcast, and he mentioned that as well, right? So he's always looking at the kind of team first, right? So looking at the people behind the product and what their idea is, instead of okay. Of course, a business model is important, but it's mostly okay. Can these guys like adapt? Say, for instance, the business model doesn't work out in that sense, and then we need to change it. Yeah, are they able to adapt to that situation as well, right?
Yeah, and I
Uh,
think that's even more important for business angels, especially if they are not professional business angels. Like they really get to, I mean, they have some money, they can do something with it, and they really need to get excited into something that they will enjoy. So it's probably more than the investment, because they just want the money in return, which is of course extremely important.
yeah.
But if it was just the only thing that motivated them, they probably go for another alternative, like probably safer, or even, I don't know, yeah, safer, I would say.
Yeah, there are safer investments
Exactly.
than a startup. Yeah. So I want to get back to your product. What I first would like to know is, where did the name Plastic came from?
That's a very good one. So, okay, uh, we wanted to have like a cool name for the product, and we wanted something that, a name that you could use in any language, because we wanted to go international from day one, right? Which was, you know, uh, not easy to start with, but that was the goal. So we thought about different names and how could we call it, and then we ended up saying, okay, we'd like the version control to be flexible, and also to protect everything that is inside, and to be like, also very important what I said at the beginning, a word that didn't have any bad meaning in any language, right? There are many jokes about products or cars or something that end up with weird names in some regions. So, well, that's how we ended up with plastic, which was very short and meant basically the same. We always say the flexibility side of things, although know plastic as a material doesn't need to be flexible at all. It can be pretty rigid, but that was basically the goal and how we named it.
Yeah, and could you, for the listeners that don't know it, could you explain a little bit about what it is besides just the version control system?
Yeah, okay. So plastic is like I mean, everybody knows Git these days. In fact, we started not the same day, but the same year they released Git.
Mm-hmm.
So plastic is a distributed version control system that can also work centralized. So it's like, you can think about it like Git with a few more things. It's not based on Git at all. I mean, it's or entire code stack or entire technology, but you can think about it like, okay, it's Git plus support for big files, a lot of visual tools built in into the product, support for permissions built in into the product too. You can also work centralized, as I mentioned before, which means you can work in Git mode, local repos, or directly doing check-ins to cloud or a distant server like you will do in Perforce or Subversion or any other system. So this gives you a lot of flexibility because you can have, for instance, we have many customers in games. I mean, we didn't end up developing a game, but we have many customers there. So many of them really appreciate, like for artists, like artists in game development, they prefer to just check in, while developers prefer to go the push pull. And also, they all appreciate the big files and big repos. Like we have customers with repositories that are bigger than 4 or 5 terabytes or something like that. We also have like a cloud service, Plastic Cloud, and then the average repository there is about 50 or 60 gigabytes, which is much bigger than what you can find in, I don't know, the GitHubs or GitLabs of the world. So these are basically some of the features in Plastic. So we try to make it super usable. We try to make it super simple, but also very powerful. So like the merge mechanism we provide is far beyond what anything you can find. And we also develop things like semantic merge, which is basically a diff, a merge tool that understands the code. So basically it's based on parsing the code prior running merges and so on. So it's like, super nice to reduce merge conflicts and to make things simple.
Yeah, and I was when you were talking about it is the full stack, right? So when we look at Git, it's usually just you can create the repository locally and stuff like that, but you have a whole ecosystem around it with actual servers that you push to. But you do that all in house, right?
Yeah, exactly. I mean, Git is super big and super important. It's a great product, so uh, comparing against it is not easy at all. It's not that we always compete, because many teams simply cannot use it because this or that. And the fact that Git is so widespread helped us also because it gave us a lot of visibility. So 15 years ago, nobody knew about distributed version control because it basically didn't exist. There were only like a few alternatives here and there, but they were not mainstream.
Yeah.
Nowadays, everyone knows that and knows how important it is to work in branches, short-lived branches, do merges, and all that. So that helps us a lot, right? Every customer that comes to us basically says, "Okay, I cannot use Git for this and that, so I need something different." So Plastic is the way to go. So, yeah.
So that's a good point to segue into is why do clients prefer your product over, for example, Git? So what are kind of the shortcomings of Git that you can provide with your product?
Okay, the customers that come to Plastic from Git, that they basically leave Git, is because of one of these reasons. Whether they need super big repositories or handle big files and LFS is not a good choice for them, for whatever reason. They want to work centralized and distributed at the same time, or even just centralize some of them. Normally, the typical scenario is probably like a mixed one. Some people working in push pull, some working only in check-in mode. You cannot work in check-in mode only in with Git. Then the next one is file locking. Again, in games, like it's not mandatory. It's not like in Plastic you need to lock. It's like an option, but we have optional file locking. So if you're working with files that you cannot merge, like scenes in Unity, like binary content, like assets, like stuff like that, you prefer to lock. That's one of the key reasons to come. And then there's also another reason, especially in corporations, related to security. Like we have super fine-grained permissions. Like you can say, okay, you can set access control lists to branches and repos and labels and almost any object. And these are basically some of the key reasons. I'm also very proud of our branching and merging mechanism because many customers think it's much powerful and easier to understand than Git is, but I wouldn't say it's a main reason to switch. Basically, they all come because of the big files, big projects, and unlocking.
Yeah, and the branching is a good point to go to as well. Is that you do it a little bit more differently than Git, but when I saw it, I already said like, okay, this makes sense, right? So this is a little bit easier to understand what the actual branch is, right? So could you explain a little bit of the difference?
Yeah, absolutely. So when you're using Git, you have to make sure you understand how branches work. And basically, branches in Git are pointers to the latest commit on the branch. So you have a pointer to a commit, and you walk back the tree, and then you get a branch. But it's not that easy to know sometimes whether a commit was into a branch or into another or something like that. Maybe it doesn't really care. It doesn't really. I mean, you don't really care. It doesn't really matter in Git in some scenarios, but sometimes it's pretty useful to know I created this commit on that branch. And that's how it works in Plastic. So while branches are pointers in Git, branches are commit containers in Plastic. So every commit goes into a branch. And there's no way you can have a commit in two branches like it can be in Git. So it's just different in that sense. It's pretty similar in some other points, but it's super different in that sense. And I will say it's easier to get. I mean, in almost every Git training you see or you attend is like there's one section devoted to talk about how branches work on these pointers and making sure everyone understands that. And that's something we simply don't need to in Plastic because branches are mostly how you would expect they are.
Yeah, so looking at the way Git does it, it's basically one. Can you call it one branch? I think it's like one branch, right? So it's one main line, if you can call it like that. And it just points to a particular point in the line, right? Something like that.
Yeah, it's like a label you attach to a given commit,
Yeah.
and then the commit has a parent, and then this commit can have another parent and so on. Then if you walk back the line, you can assume that's the branch. But it's not always like that because there are points where you really cannot know if a commit is in one branch or not. There are some ways looking into the ref log and stuff like that, but that's pretty advanced. So the regular user cannot know that. I
Yeah.
mean, I wouldn't say it's just a different way. It's a different
Yeah.
design approach. I mean, it's like Git has many advantages thanks to that because it's lighter to do imports and so on. I'm not talking about whether it's faster or not. I would say yes, it's lighter to do some stuff
Sure.
like imports and so on. But from a usability perspective, I think containers are better. Of course, I'm biased. I mean, it's a system I designed. So
Of course, but
yeah,
I understand. So so it's in Plastic, a branch is actually really a separate thing, right? So it's not connected to the other commits that you have maybe on your other branch. Is that correct?
exactly. I mean, it's more like a container. I mean, it's
Yeah.
like okay, I want to create a branch. You will create it exactly as you will doing in Git, and it's super fast, and it's not like a copy or anything else like it used to be in Subversion. No, it's not like that. You create a new branch, and it's just saying, okay, now this branch is pointing to this commit. But as soon as you create a new commit, we call it a checking or a chain set. Then this chain set is in the new branch, and there's no. I mean, there are ways to move it, but it's not like the regular thing. And when you merge it, it doesn't. It's not just like another branch pointing to it or something like that. No, the branch is really like a container from a data model perspective. Think of it like if every commit has a field called branch ID. So there's a one to many relationship, one branch, many chain sets, but it's not like many to many, let's say.
Yeah, and I can imagine that a lot of clients that want to switch to Plastic are a little bit hesitant, of course, because they have a whole ecosystem running on their on Git and stuff like that. So is that would you say that is one of the things that is kind of hindering people or maybe diverting people from switching over? How do you look at that?
Okay, that's a very good point. I mean, obviously I have a lot of respect to, well, I respect all the competitors we have, because otherwise I will be quite dumb, and I hope I'm not. I mean, I am.
No, no.
I'm not. So I really respect all the other competitors. So obviously it is super good. I mean, I think it's super cleverly designed. And one of the advantages is, as you mentioned, the entire ecosystem. So we find ourselves many times, very often, developing the entire stuff. Like we have to go and develop a plugin for this and that or that, while in Git, the developers of this other certain system, they make the job for themselves. So yeah, that's definitely something that might prevent some users to say, okay, I like to go for Plastic, but hey, they don't have such a big ecosystem and so on. So the way in which we try to overcome that was making Plastic compatible with Git as much as we could. What I mean by that, any Plastic server can act as a Git server. So you can basically push pull from a command line Git to a Plastic server, and Git thinks it's another Git server, right? Or regular Git one. So this is one of the things we did. And it basically lets you connect your Plastic server. Suppose you're running an on-premise Plastic server, you can connect it to a service that only allows to use Git, right? So that's one of the things. The other one is that any Plastic client can act as a Git client. So I can be with my command line in Plastic or my GUI connected to my local repository. And then I can go and push to GitHub, for instance, or pull from GitHub. And it works pretty well. Like, I mean, I can have a couple of branches in my Plastic repo, push them to Git, do the merge in Git, pull back, and then I get the merge in Plastic, or vice versa. Suppose you want to get to benefit from the better technology or the more advanced merge technology we have. You can have a Git repo in GitHub, pull it to your local Plastic repo, do the merge in Plastic, and push it back to GitHub.
Yeah, that's one big thing, and of course, you mentioned the GUI in there as well, and that's something that I want to just go into a little bit, because I've seen some examples of how it looks, and there seems to be a focus on actually getting that GUI right. So why is that? Because most of the people will say, okay, just give me command line and that's it. But you also have a good focus on the GUI as well. So why is that?
Okay, so we found over the years, and it was also one of the original intents, that we wanted to make version control accessible for everyone. So there are many developers who prefer to use a command line, but there's a vast number of developers who prefer to use a GUI. I mean, it's like, what do you prefer, IntelliJ or Vim?
Mm-hmm.
Many users will say, okay, I prefer IntelliJ or Visual Studio Code or full Visual Studio, whatever, right? So we wanted to basically do the same with Plastic. It's like, okay, if you are a command line geek, okay, you can go and use Plastic from the command line, and that's good. But if you really want to use it from a, more high level perspective, like really taking benefit of visualizations and branches and divs and so on, you have a powerful GUI. And then we developed like native GUIs for Mac, for Linux, for Windows. And we have like the built-in div. It's like a side-by-side semantic div, which shows you if you move a method to a new location, shows you that with beautiful representations and all that. So it was really a lot of work. It's still a lot of work, because you never end up making it better and maintaining it and doing tweaks, and then you find something you did a few years ago is not that good or that usable anymore. So we are constantly creating new versions and releasing new improvements. But yeah, that's something we did, and we think it provides value to the type of customer
Yeah, and
we work with.
I've noticed that as well. I had a similar case within the team that I was leading at the time, where, for example, the designer and the front end developer, maybe more the designer even, was they use the GUI, right? So they really use the GUI. In this case, it was the Git GUI, but I think it was GitHub GUI actually. But they use that GUI because it was more visual, but also it was easier to understand that way than just an abstract command line, right? Is that also one of the reasons?
Absolutely. I mean, for instance, artists in video games and non-programmers, I will say, they really prefer the GUI. In fact, we have a special GUI for artists. Like we have like the developers GUI, and then we have a GUI for artists and people who are not coders. And that's one of the key reasons why they come, right? So that might add some value for them. But even for developers, there's something interesting that happened. In the early days, we all used the plastic command line down here, right, at the very beginning. And then we found ourselves moving to the GUI. Even hardcore command line guys prefer to be on the GUI if the GUI is not just a wrapper around the command line. I think, especially at the beginning, I think now they are getting much better. But at the beginning, many Git GUIs were just like wrappers of commands. Like you were basically supposed to do exactly the same, but just hitting a button instead of running a command. And then probably doesn't make a lot of sense, right?
Yeah, and it's frustrating to work that way. I've noticed that as well myself when I tried it. I was like, okay, yeah, but really, why am I doing this in a GUI when I can just type this into the command line, right?
Exactly. I mean, there were even GUIs that showed you the command and the underlying command again and again, which is good to. It's probably good for some type of users, but it means you are not designing the user experience. Really, you are just wrapping whatever you can do on the command line. So what we try to do, and it's hard to tell whether we really succeeded on that, because as I said, it's always an ongoing process, and I'm always seeing problems here and there, right? Like, okay, I want to improve this, that, which I think is the regular thing for a developer, right? You always see like the bad side of things because you're focused on making it better. But what I wanted to say is we really designed it like a different thing. I mean, it's not like a wrapper on top of our command line because we have our own command line. No, it's really a different thing. It's built to work as a GUI. So there are things that you do in a different way than you will do from the command line, right? And for instance, at the end of the day, what you use most intensively in Plastic is what we call the pending changes, which is like git status or something like that. But we use it from a GUI. I mean, we have a command for that, but we also have like a GUI. And then it's like, okay, you see the list of changes. You can immediately see if you move a file because Plastic detects moves. That's one of the things we do super well. And then it shows you a diff in a visual way, and you can, understand even you move a method or something like that. So it's like you just go there, type the comments, hit check in, and you're done. So it's not slower than it will be on the command line at all. It's pretty visual, and it's mostly what you do, right? It's like, okay, you can be doing merges and branches and all that, but you do check-ins much more often than you will do all those. So yeah, it's really designed to be working in a visual way, and yeah.
Yeah, that's interesting. So what I was wondering about as well is that how do you create a business out of this, right? So how do you put a business model on top of this? How do you go about that? How did you do that?
Well, it changed a little bit from the early beginnings because initially we built basically a license model, like you pay for perpetual licenses or something like that, and then you get Plastic, and that's it. And now we still have this type of customers, and especially in big corporations and so on, but we basically move more to a SaaS type of business, like subscription based. So you pay a monthly fee or something, and then you get access to the software and also the Google, the cloud storage if that's a product you use, this kind of stuff. So how we build a product out of that? Well, a product, a business. Well, we decide a pricing model long ago. We didn't move pricing that heavily on the last few years. We are very affordable. We try to position ourselves cheaper than most of the competitors. Not cheaper than the free ones, of course, because we need to make
That's
a
hard to
living
do.
out of it. Yeah, that's hard to do. But that basically, as I said, the goal is what's the difference? What's different? What's the value? And our goal is, okay, you know what? You can work in task branches, except if you are an artist, where all you want to do is something simple, where you just want to check in and you're done. But otherwise, if you're a developer, you probably want to work in short task branches that you merge quickly back to the main branch, and then the test pass there, and then you reduce the lead time for every task, and the task time from open to deployed is shorter. So we basically give you the tools to implement this sort of methodology. So it's not that we are, methodology gurus or something like that, but we really give you the tools to implement a way of working where you will move tasks forward faster, where you will deploy faster to production, and you stick to a few rules. And if you use Plastic in this way, you'll succeed into that. And that's basically the business, right? So the business is user tools to work in a better way you will do without them. and that's why they pay for, because they have all the customers we have, they have free alternatives, so they are willing to pay us because we provide them with extra value that they don't find in cheaper or even free competitors.
Yeah. And what I was thinking about while you were talking about that, because you mentioned the binary files before, that's actually a good point, because I remember that I was working at an internet agency as well, and they had a problem with the designers, as in they had like Photoshop files, right? So they were like, okay, but we need to version these files somehow. And I don't know if Photoshop built that in later on, but that was one of the things that was not really available, right? So there was no way to kind of version your files in that way, especially the PSD files that Photoshop creates. Is that exactly the kind of binary files, as you said, you mentioned the game developers, but are those kind of the binary files that you also version? And how do you do that? Because that a binary file is not text where you can just diff it and say, okay, this is differently. How do you do that?
Well, yeah, exactly. I mean, when we say binary files, we say everything that basically cannot be easily diffed or merged, right? That they are not text-based. So code is very easy to diff and merge. We even have this semantic technology to actually dig into the structure. That's something else. But yeah, if you have like a DLL, or you have an executable file, or you have a PSD, or if you have like a video or something like that, then of course it's not that easy to diff. You need a specific tools to do that. I'm not saying it won't be the future where you can easily diff all that, but right now it's more like a blob that you have to put somewhere, right?
Yeah.
So the benefit with Plastic is that we are finding in many teams that they have big binaries, and they also have codes, and then many of them have like, okay, Git in one side, and then they have like a Dropbox on the other. So it's like a mess, right? So, and it's all because they cannot simply go and checking everything into Git, because Git is not designed to do that, right? So the main benefit they get with Plastic is, okay, you know what? I don't care whether the video is 100 megs or 1 gigabyte. I can just go and check it in, and it will work, and nothing will break, and I don't have to go and repair the repository because it will break or something, or I don't have to go and remove my project from GitHub because they ask you to have projects smaller than a certain size or something like that. So that's the main benefit, right? And yeah, if you ask me how we do it, well, it's basically a design decision we made at the very, very beginning. It was like, okay, how can we handle big files? And we decided to go into this very simple approach, which is, okay, let's split them in chunks, and then let's store every chunk separately. So you never end up handling more than 4 megabytes together in memory or together in the network or something like that. Of course, you stream them through the network, you send them through the network, but we are always working in chunks. And that's one of the things that makes it possible, because many other version controls try to like calculate a patch or something, load in the entire file in memory, and then they simply die if the file is too big.
Yeah, because especially when you look at the big Photoshop files, but also the game developers, they can be multiple megabytes, right? Which just doesn't fit in your normal laptop memory, for example.
Yeah, exactly. Or even if they do, it's a lot of overhead, and then it's simply whether the system is meant to handle that or not, right? In our case, as I had said, we have customers with repos that are 5 terabytes, and it's like wow, it's super big, it's about to break. And it's like, okay, I don't care whether it's 5 or 10 or 8 or 2 or 100 megs. It just works, right?
Yeah.
It's like it is.
And I wanted to look a little bit into the future. It's basically one of the last two questions that I have for you as well for today. So where do you think this kind of collaboration on code and the way we work, especially for developers, but also for the designers and the game developers, for example, where do you feel that's moving towards?
Okay, there are several things, right? We are constantly thinking on that. What's next? What are we going to do next? What's going to be the thing that is going to make the life easier for users, right? And there are a few things. From a usability standpoint, I think we need to make everything simpler. I mean, I think the iPhone of version control is yet to come. I mean, we really need to make something as simple that you don't have to make much effort to use it. And still, I mean, it's hard to see for us because we are all day developing version control and we are experts on version control. So it's kind of okay, everything is easy, but it's not, right? So one of the key things is to make everything much easier. It doesn't mean it has to be less powerful. It just has to be much easier, especially when you're starting. So that's one of the things. It's not very fancy. It's not super big technology or something. It's just make it simpler. The other thing goes more into, from my point of view, goes more into extracting the value of repositories. So at the end of the day, every project is storing a lot of information into repositories, but they don't benefit that much out of it. It's like, okay, I have 10 years of code in my repo, but is the repo really giving you some insights? It's really giving you, teaching you lessons of mistakes you made. It's really helping you find hotspots in code. It's really letting you figure out if what you're changing looks good or not. So we are thinking on approaches with machine learning and really extracting data from big repositories from history and all that, and trying to come up with hints, suggestions, highlighting stuff, things like that.
Yeah, and
Also, yeah,
yeah, go on. Sorry.
yeah, well, we are also very interested on semantic technology. What we call is semantic is basically, as I said, parsing the code before calculating diffs or merges. This is super good if you refactor code and so on. So one of the things we do right now is you can calculate the history of a given method in Java or C#. Like not just the history of a file, but the history of a method. And but that's something we've been doing for years, but we think there's a lot of room for improvement. Like right now, it's something we calculate on the fly, but I think we could have like pre-calculated history, so it's super fast, even when the method moves across files and stuff like that. So you can really understand if you're touching a hot spot, right?
Yeah.
Because right now you refactor the code, you move it to a different file, and then it's like, okay, it's new, and you're probably missing that this particular method has been around for like 5 years and was touched a million times. Well, not a million, but a lot of times, and it was involved in a few merges, in a few bugs. So you must be careful the next time you touch it, right? Because probably you are about to enter a new bug or something. So these are the kind of things that you can probably benefit from. And also, there's something on the process side of things. Like we always wanted to be very process agnostic. Like, okay, we are just a version control. Let's do our work well and don't mess with the Scrum or Kanban or something like that. We still think that, but we see that customers really appreciate when you are opinionated and when you really tell them, look, if you do this and this, you will get those results, right? So we are trying to be more helpful in reducing some key metrics like cycle time. Like everyone is really interested on, okay, from open to deployed, what is that time? And I think version control can play a key role there as a orchestrator for DevOps.
Mm. Yeah, that's really interesting. Especially the thing that you mentioned about the methods being switched around. So that happens a lot, right? So we create a new module and say, okay, things that were previously in this module together, we're gonna split it because we're creating a microservice or whatever, right? So it can happen that something moves and you don't even know that it was in that particular file at one point, right? That's what you were mentioning.
Exactly. In fact, right now, today in Plastic, we have something called multi-file diff. So if it detects some method that was moved from one location to another in a branch or change set when you're diffing that, it will tell you and you'll be able to diff the right thing, and it will even show you a diagram showing you how the methods were. So sort of a class diagram, not exactly a class diagram, but like a really simple class diagram showing you, okay, this method was moved from here to there. That's something we do today. But I think we think in the team here that there's really a lot of room for improvement, a lot of things we could do better and more productive and more helpful, just putting a little bit of intelligence in the data that is inside the repo.
Okay. And to wrap up, I have one more question. So, what are you most proud of since you started on this whole journey? Because it's been a while, but I just want to know what are you most proud of up until now?
Okay, if I had to select a single thing, I would say that the thing I'm most proud of is the fact that most of the team that started here are still here. So over the years, over the 14 years we've been in business, mostly everyone in development stayed here. So it means we have a challenging project. It means we have something that keep people, motivated, and it means we created the right culture of the right environment so that people prefer to stay instead of going to another company. We have people here with 14 years experience. They just entered at the beginning and they are still here. we have people who have been here for 8 years, 6 years, 5 years. I mean, we tend to be so long here that we still call the new guys to people who have stayed here for like 4 years, right? So it's called off. So that's something I'm proud of. I think besides technology, besides the product, which is being, of course, a great adventure so far, but having the sense that I helped to put together a group of people, of individuals that together can achieve great things, and they prefer to stay together for such a long time, is something that makes me quite proud.
Very cool. I think it's a great way to cut off the podcast. So, where can people find you on the internet?
Well, if they want to reach me directly, I'm at Twitter at psluaces. So it's like my second family name. And I'm always available on there. So if you go to plasticscm.com, there's a section down below called Team. And then you can see the pictures of all of us and our bios and ways to contact us. So yeah, I'm always open to engage in a conversation, and we are all quite accessible, right? So
Very cool. Yeah, I'll link it down below when the podcast goes live, of course. So thank you, Pablo, for being my guest. It was really good to talk to you.
Thanks for having me.
And of course, for the listeners, you can find the Bits vs. Bytes podcast on bitsvsbytes.com and also all major podcasting platforms. And of course, on Instagram, Twitter, and LinkedIn, it's all Bits vs. Bytes. And I would like to thank you for listening, and until next time.